Now pumping lemma for context-free language. If L be a context-free language and W belong to L such that length of W is greater than equal to n for some positive integer n, the W can be decomposed into 5 parts A, B, C, D, E, where B, D is not equal to epsilon and length of BCD should be less than equal to n, and for all I is greater than equal to 0 the string A, B per I, C, D per I, E is also belong to the language. And what is a pumping lemma says in context free language? Pumping lemma says that if no such pattern found, then definitely language is not context free language. But if pattern is found, then it is not sure that language is context free language. Means if the given language pass the test, then it is not sure that language is context free language. Okay, but if the given language fail to pass the test, then we can say that language is definitely not context free language. One more thing, if a language L does not satisfy the pumping lemma property, then L is not context free language. Now see what is the pumping lemma property. This is the property 1, BD, this part B, part of the string BD should not be epsilon. This is property 1. Property 2, length of BCD should be less than equal to 1. Property 3, if all I is greater than equal to 0, the string AB per I, CD per I, E is also in the language. Now see, suppose this question is given L equal to x power n, y power n, z power n, such that n is greater than equal to 1. Prove that this given language is not context free language. This is the question. Prove that. This is also called negativity test, because pumping lemma only prove that the given language is not context free or not regular. It doesn't prove that language is context free or given language is regular. Okay, now see, this is the given language. The question is prove that this language is not context free language. Similar like a regular language, pumping lemma for regular language. Okay, now see, now we can take n equal to 1, 2, 3, 4, anything. If n equal to 1, then it is the string is x, y, z. If n equal to 2, then next string is x, x, y, y, z, z. If n equal to 3, then string is x, 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 y, 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 z, z, z. If I am taking n equal to 4, then what is the string? Then 4 times x, 4 times y, 4 times z. This is a string of this language. Okay. Now divide the string in 5 parts A, B, C, D, E. Okay. Now suppose I am taking second x and third x as B, and first x is a and second and third y is a D, and fourth y and all z as a E. Okay. Now this is a and it's a B, and x y is a C, and the second and third y is a D, and y and all z is a E. I have divided in such a way that first x is A, second third x is B, last x is, and first y is a C, and second and third y is a D, and last y and all z are E. Okay. Now pump B and pump D. Okay. Pump means, see here, B per I equal to, you can take I equal to 1, 2, 3, 4, 5, 6, anything. Okay. Suppose I am taking I equal to 2. If I am taking I equal to 2, then pump B 2 times and pump D 2 times. If we pump B 2 times, then what is the string? Then x, x is already there 4 times. If we pump B 2 times, then there are 6 times x, and if we pump D 2 times, then there are 6 time y, 6 time x, 6 time y and 4 time d. This string 6 time x, 6 time y, 4 time d is not a part of this language. Means this property, third property, is not satisfied by the given language. This is the third property. For all I greater than equal to 0, the string a b power I, c d power I, e is also in the language. This is the third property. Okay. If we pump b and d 2 times or 3 times or 4 times, then whatever the string will be generated, if this string is not a part of this language, means this string, means this language does not satisfy the property of pumping lemma. If this language, the given language, does not satisfy the pumping lemma property, then it is proved that this language is not context free language. Okay. Now see. Now divide this string by another way. Now suppose I am taking second and third x as a b, and fourth x and all y, and first z as a c, and second third z as a d, and last z as a e. If I am taking like this, then pump b and d. We can pump only b and d. See, we can pump only b and d. This is given in a rule. Now see. Now pump b and d. If we pump b 2 times and d 2 times, suppose I equal to 2, then pump b 2 times and d 2 times, then there are 1, 2, 3, 4, there are 6x and 4y and 6z. Okay, 6x, 4y and 6z. 6x, 4y and 6z is not, this string is not a part of this language, because equal number of x, equal number of y and equal number of z, all the string which belong to this language, that is equal number of x followed by equal number of y and followed by equal number of z. Okay. If we pump x, b 2 times and z 2 times, then there are 6x, 4y and 6z. Means this is not equal number of x, equal number of y and equal number of z. Means now after pumping b and d, this string, whatever the string will be generated, this string is not a part of this language. Means this property, third property, is not satisfied. Third property is not satisfied by this language. Means this language, it is proved that pumping lemma has proved that this language is not context free language. Okay. Now see, take this same string, take the same string 4 times x, 4 times y and 4 times z, and divide by some another way. Okay. Now suppose first 3x is a and last x and first y is a b, and second, third, fourth y and first z is a d, is a c, and second and third z is a d, and last z is a e. Now pump b and d. Now what will happen? Then 3 times x, if we pump b and d 2 times, then it is 3 times x, xy, 3 times y, z, 6 times z. Okay, 3 times y, 6 times z, and 3 times xy followed by xy, x followed by y, then x followed by y. Now after pumping b and d 2 times, whatever the string will be generated, that is not a part of the given language. Means third condition is not satisfied. So we can say that this given language, this language does not satisfy this property, third property of the pumping lemma. So we can say that the given language is not context free language. Okay, and this is also called negativity test. Pumping lemma is a negativity test. If any language fail to pass the pumping lemma property, then we definitely say that language is not context free. But if any language pass all the property of pumping lemma, then it doesn't mean that we'll say that language is context free language. Okay, so this is all about context free language. Okay, thank you.